Kushone kuyaphekwa, kuphekwe throughout. Angazi yazi. Ikuphi la kuthengiswa khona inyama gogo? So ungakhona ukuthi uye ebhlafu kusasa. Okay, right. Ngizothumela imali uye ungele ebhlafu and then sibone ukuthi sibathengele inyama engakanani. Yabo nje kwama bengithi thenga inyama uthenge nama-veg. Yebo, gogo kuzobe kuphekwa almost every day. Negogo. Ngizothumela yazi. Tiyama, stop, stop.
Friend. We'll talk tomorrow.
All right. Good evening, everyone. I welcome you to another session of statistics. If maybe there's someone new and it's your first time getting into this lecture of statistics, I kindly encourage you to go back, to the last recording that we did last week. So just make sure that you get a hold of James or maybe Jasmine, the one that you're in contact with in your groups, and kindly request for last week's recording. At least it will give you an overview of what we did last time. If you want maybe to catch up with this lecture that we are doing today. So I trust all of you are fine. And I want to thank you for tuning in for another free lecture. All right. So today, last week, we did an example of an assignment, right? Not yet. I haven't displayed anything as yet. So don't worry. You should be seeing the black screen for now. I'm going to share the screen in a moment. All right. So I was saying that last week we were going through a simple assignment so that you can appreciate, the method of delivery and how we conduct this lectures. All right. So later on, I will have an assistant lecturer. As for now, is still not around, but you'll see later on when we go on that I'll be allowing him to take one or two lectures with you. So he's an assistant lecturer. So we will be together in this module. So today now, what we want to do, we want to start with the slides so that you can have an overview of how we deliver, right? How we deliver these slides now. So last week we were focusing much on the the method of delivery. Now you are getting to see how our slides will be like. So let me share the screen now. All right. All right. Okay. Perfect. All right. So this is an overview of this lecture. We are not going to cover everything, right? Remember, this is a free lecture, so we are not like starting, with the deeper things. So I'm just going to start with a part of the slides. I'm not going to cover everything. So maybe I'm going to cover, what is statistics, type of statistics, and data presentation. So measure of central tendency and measure of dispersion, we'll see them next week, right? When we start with those that would have joined us, right? So for a recap, right? Let's start by defining statistics, right? I know I defined last week, but last week, like I said, it's just an overview. So now we are starting everything afresh, right? So I'm assuming that maybe some of you were not present last week. So that's why we are starting to redefine, the term statistics itself. So statistics is a way of gathering. That's the first thing. Secondly, organizing. And third, interpreting information from so in other words, it just helps you to gather data, to classify, to summarize, to interpret, and then draw conclusion from the data. All right, let me see. Okay. So someone saying they just joined in today. Okay, that's fine. Don't forget to ask James for the recording for last week so that at least you can have an idea of what we did last week. All right. So what I want to say today is right now is statistics is all around, right? When you're at workplace and you see figures, chances are it's statistics, right? So when you are talking about income, profit, turnover, levels of production, forecasting, etc. I don't know the terminologies that you are well acquainted with, right? In your specialization in terms of work, right? But whenever you see these things coming up, it should give you an idea of what statistics is all about. So generally, statistical reasoning is all about being able to accurately interpret results, right? So, okay, what's happening? All right. Okay. So now, still on statistics there, we said that it involves gathering of data. It involves classifying data. It involves summarizing data. It involves interpreting data. It involves drawing conclusions from the data, right? So it facilitates what we call the informational presentation of data to support decisions that are needed, right? So let me give you an example here. So let's say, because let's say that you are part of management, right, at your workplace. And then obviously the management guys are the ones that are responsible for making decisions. Maybe depending with the level of management you are at, right, there are certain decisions that you have to make, right? So obviously, let's say, for example, you have been making some sales, right? And you want to check whether for the past 5 years you have been operating at a profit or you have been operating at a loss. So obviously what you do is you go to the sales department, you request for all the sales that were made for the past 5 years, right? So what you do now is you have gathered the data, right? Now you need to classify the data, you need to summarize. So definitely you use a statistical model, to analyze the data. Then after you analyze the data, you need to interpret the data, right? So when you interpret the data, then maybe you get your conclusion. But now remember, you are not the only person in the management, right? So obviously you make a decision as a group of people. So you need to present that information that you would have drawn out from that data. You need to present it to the other guys. So there has to be another way where you can present the data. So you use also statistical ways of presenting the data. So now you are using statistics to gather, to classify, to analyze, to interpret, and to show the people the presentation, right, of the data. After you do that, then you make decisions. You be like, guys, you can see from the trend of this data that we have, right, we are operating at a loss. So let's try to implement other strategic, some other strategies in order for us to increase the sales. So obviously that decision of changing the strategies, you would be informed by the statistics, by the data that came from statistical analysis. All right, so that's why we are saying that statistics is used to make informed decision. All right, so now let's look at, so now we are covering a little bit of theory. So it's not all of the theory, because some of the theory we're going to cover them a little bit later on. So this is part of theory, right, of Unit 1 and Unit 2. So let's discuss the types of statistics that we have. So we have two types of statistics. We have what we call descriptive statistics. So this is the statistics that is used to summarize, to describe the data using frequencies, percentages, measures of central tendency, measures of dispersion, and also looking at what is called the shapes of distributions. So generally, when you're talking about descriptive statistics, in a nutshell, it is the statistics that is used to describe the data. So you use descriptive statistics to describe the data. So you describe the data either by using frequencies, or using percentages, or using measures of central tendencies, like maybe you're using your mean, your median, or your mode, right? That's the first type of statistics. Then the second type of statistics is what we call inferential statistics. So inferential statistics, generally, this is the statistics that is used to make inferences or a generalization about the population from the sample which was drawn. So let's say, for example, we want to find the relationship between employee satisfaction and organizational performance, right? So what we're trying to figure out is if an employee is satisfied or not satisfied at work, how does it apply? How does it influence the performance of the company in general? Right? So that's what you want to find. So this has to apply to all the companies in South Africa, but you can't go to each and every company in South Africa because there are so many, right? I think maybe in your neighborhood where you're living, or maybe let's say where you work, if there are any industries, you can't go to each and every company in your neighborhood, right? Or where you work, because there are so many. Just imagine in South Africa. So there are so many companies there. So what you do, instead of going to each and every company in South Africa, you take a sample and then you say, maybe I'm choosing a company that I'm going to take information from. So you go to a company, right? Maybe your company, and then you make a questionnaire, right? That asks information about employee satisfaction and information about organizational performance, right? And then you find out that there is a relationship, right, between the two, right? Which is the case. Because if an employee is not happy, obviously they will not put their best effort. So obviously it will affect the performance of the company. So obviously you have found that there is a relationship. So you use what is called inferential statistics, where you make inference or you make a generalization about the whole population of South Africa based on a sample that you have done. So you just do a sample and then you generalize it to the whole of the population. So that is what is called inferential statistics, right? So a very good example that I gave is when you are calculating relationship. So when you are calculating relationships in statistics, it's a type of what is called inferential statistics. All right. What is happening to my button here? Okay. All right. So now let's look at data presentation. So I talked about that after you have maybe gathered the data, right? And then you analyze the data, you interpret the data, right? Now you want to present your data to your audience, right? So there are various number of ways that are used in statistics, right, to present the data. So the information obtained from a statistical analysis is meaningful to business managers only, right, when it can be interpreted and communicated effectively and concisely. So obviously, if you can, okay, someone is asking, is class started? Yes, the class has started. If you came, if we came, a bit late, right? Just wait for this recording when it comes out.
Your mother is getting spoiled. Eh?
Okay, guys, please kindly mute your mics if you join in. All right. So what I was saying is it's pointless that you interpret data, you gather data, you analyze data, you interpret it, and then you don't communicate it perfectly to your audience. So it means that you have done all those steps in vain. So you must be able to convey your information vividly to your audience. So it is customary to convey information through use of what we call tables and charts. So tables and charts are example of ways of presenting data, and these ways they convey information more vividly and quickly than written reports. I'm going to show you using an example in a moment now, right? So using a table to list data according to categories is often much clearer than writing out the information in a paragraph form, right? So, okay. All right, what is happening here? All right, so now let's see the beauty of using tables, right? So on my left side here, okay, let me try to find. So on my left side here, you can see information that you are given in form of what? Of a report, or let's say written format. So it says during the 1995-1996 academic year, a survey of the holdings of okay, Jacqueline is saying you cannot hear. Okay. All right. Wait, let me try to help Jacqueline here.
But we can hear.
Yes, I know you can hear, but I think she can't. Maybe, yes, someone saying log off and on again. Thank you so much. That's actually what I wanted to tell you. Thank you so much. I think if she can log off and log on again, I think it can help here. All right, thank you so much. So during the 1995-1996 academic year, a survey of holdings of university research libraries and rank was done in the United States and Canada, right? It was found that Syracuse University in New York had that holdings and was figured to rank 81st, and then Harvard ranked first, right? Then the University of Connecticut was ranked 50th place. The Massachusetts Institute of Technology was ranked 73rd place. So this is information that we are being told about 4 universities, their ranks, and maybe the number of holdings of each university. So you can see that I have read information, but we are not really getting what we want to get here. But on the right side, you can see that it's the same information that we are being told on the left side, but it is being presented instead of a written format. It's being presented in terms of a table. So now you can even, without someone explaining to you, you can even tell that, oh, okay, so these are universities, so these their ranks, and these are the holdings, right? So without even reading, you could take a lot of time reading it and trying to see what is being depicted, or trying to see what is being said in the text, whereas the table just tells us the information that we want at once, right? So in this case, the table is showing the information more vividly than the written format. So that's why we are saying the beauty of using tables, because tables is an easier way of conveying information. All right. So now let's look at the types of table that we are going to mainly use in this course, right? So there's what we call a frequency table. So a frequency table, basically, it shows the number of occurrences of a variable that falls into a specific range or a category. Coming back to the example that I was giving last week, you remember I gave an example of the lecturer that goes into a lecture room, finds people sitting there, and then the lecturer asks for the shoe size, right? And then they say, those with a range of 5 to 6, can you stand in that corner? 7 to 8, can you stand in that corner? 9 and 10, can you stand in that corner, right? So what they are doing is they are grouping, right, people into a specific range that they fall into. So the type of table that you make when you are grouping people like that is what is called a frequency table. So it shows the number of occurrences of a variable that falls into a specific category. So which means each and every single data point in that data set will definitely get into a specific range. So let's give an example that is there in your study guide. Consider a group of 47 males of various ages, right? 12 are between 20 and 29 years of age. 13 are between 30 and 39 years of age. 7 are between 40 and 49 years of age, 8 are between 50 and 59 years of age, while the rest are between 60 and 69 years of age. So how do we group these people in specific categories under a frequency distribution table? So obviously what we do is we'll create what is called an interval. Interval, remember, for those that were here last week, we talked about what is called a class interval, right? So an interval is just a class interval, right? The number of classes that you want to make to group your data. Then there's what we call a frequency. Frequency is just the number of occurrences, right, that falls in a specific category. So like in this case, we've got the first class, which is 20 to 29 years of age. And from the information that we've been told, there are 12 males out of 47 that have got an age that falls into that range, right? Then the second class, we've got 30 to 39, which means that out of 47 males, we've got 13 that have an age that falls into that category. The same is true for 40 to 49, 50 to 59, and 60 to 69. So these numbers, they represent the number of people with an age that falls into that range. So basically, there are a number of things that we can pick from such a table, right? So immediately we can make the following conclusions. From just seeing the data, we can see that the majority of the males are young, right? If we define what young is, so in this case, let's say that young is below 40 years of age. So we can see that a large number of people, which is this group here, right? These two groups, right? These people, they are less than 40 years. So if you add 12 and 13, you see that it is greater than these last three figures there. So which is true. So the majority of the males, they are what? They are young, okay? So this is just by observation. Then by observing the table, we can see that most people, they lie between the 30 and 39 years of age. So obviously, when we come to the table, we see that the highest number of males, they are under a category called 30 to 39. So obviously, most males are from that range, right? Then the last thing is when we add all the number of males under each and every specific range, we will see that it will give us 47, right? So if you add 12, 13, 7, 8, and 7, you must get 47, the total number of people that took part in the study. All right. So now let's go to the next type of a table, right? So there is another type of table which is called a cumulative frequency table. So this is it's building block, right? It's from the frequency table. I'm seeing someone has raised their hand. Kindly unmute yourself if you have a question. I'm seeing that Lindy raised their hand here. Just feel free to unmute yourself if you have a question.
Can you hear me?
Okay. I can't hear you. Hello?
Hello?
Yes, now I can hear you.
Thank you, sir. Can you kindly go back to the previous slide that's got the example?
All right. Okay, this one.
Yes, I just want to understand the last one for 60 to 69
Okay, this one,
of
yeah.
years. The number of males, which is 7. How do they get that? Or is it because the whole group is 47 and then you break it down? Because I see at the last sentence, is it supposed to be like they didn't mention the 7? So
Yes.
okay.
Yeah, you're
I don't want
actually
to assume. I don't want to assume. I just want to make sure that it
That's
is
actually correct.
accumulative.
Yes.
Okay.
because I'm the one who made the assumption in the first place. I was supposed to explain that. Thank you so much for bringing that up. Okay, so what she's asking is, you can see that from the last statement here, we are saying 8 are between 50 and 59. We can see that these are 8 under this range. Then they say, why would the rest are between 60 and 69? So we are not told here that they are 7, but here they put 7 here. So what she is saying is correct, right? Because we are told that it is a group of 47. So obviously we will say 47 minus 12, right? And that remainder will subtract 13. That remainder will subtract 7 and 8. So when we subtract all these 4, you will see from 47, you will see that you get 7. So that's 7. You get it when you say 47 minus 12 minus 13 minus 7 minus 8. So you are actually correct there, right? So all this number of males at the end of the day, they must add up to 47. All right. So you were correct on that one. All right. So now let's go to this other type of table is called a cumulative frequency table. So basically what this does is you have your class interval, you have your frequency, but then under your frequency, you are doing what is called cumulative frequency. You are adding up on all the frequencies, right? Like in this case, okay, let's go back to the question, right? So this example, we want to explain about the cumulative frequency table, but we're going to use this example, right? So consider a class consisting of what? Of 100 students, right? Suppose the teacher gives the entire class a statistics test, which has a maximum mark of 100. Upon marking the scripts, which are in no order whatsoever, he puts the marks into a table as shown below. This presents raw data since there is no set order of the marks. So obviously, these are the number of marks that for each and every student, right? And there are 100 of them. So they are in no particular order. So obviously, we want to group them, right? So what we do is we create these classes, right? So the first class, we have a lower limit of 0 to 9. The next class, 10 to 19, 20 to 29, and so forth up until to the last class day. Then we will say how many people from the previous data have got a what? Have got a mark between 0 and 9. So you have to scan throughout all of this data to see how many people have got marks between 0 and 9, and you see that it's only 1, which is this value there, which is 8. I'm seeing Itumeleng has raised their hand. Kindly unmute yourself if you have a question.
Okay. Yes, thank you. Sorry, man, the interval of saying we're gonna go with 10, 10, 10. Is it mentioned in the, let's say for example in a question for stats, would they tell you what the interval, or you would just have to suss it out and see what's the accurate interval to use?
Okay, so that's a very good question. All right, so there are two ways. So they might, like in this case they didn't tell us. This example, they didn't tell us, right? So you're the person who wrote this study guide then used their own interval size, right? However, if you are not told, you can create your own. However, what happens in this module, unless maybe they start to change with you guys, if they give you a question and it has questions regarding this frequency table here, they will tell you, like the last example that we did, we were told that the lower class was starting with the lower limit of this value, and we were told that the class width was this value. So they will tell you. So they've got a way of telling you, but you just have to understand, right? That if you are given this data, then how do you calculate the intervals? So we are assuming that they have not given you the table, But most of the case, they just give you a table like this one. They'll just give you a table with all the intervals and the frequencies. Normally, that's what they do, unless maybe they change, and then they will tell you maybe you use this class with and so forth. So don't worry about that. They will give you information that will allow you to have the same classes, because remember, they want to mark each and every person's assignment using the same marking guide. So obviously the classes have got what? They've got to match. So they'll give you an assignment where they give you the class intervals. But however, let's say they choose not to give you, then you as a person who knows statistics, then you are free to come up with your own class intervals that are within the range of the data that you are given. So in this case, obviously, the lower mark will be 0, and the maximum mark that a person will get is 100 or 99, right? Yes, Willie, you can unmute yourself. I'm seeing that you have raised your hand.
Yeah, sorry, I'm just looking at this table, right? Why is there
Yes.
space between 2029 and 3039?
That was a mistake. You know, these guys also who write your study guide, they also make mistake. That was a mistake there. So let it not confuse you. Okay. So he's asking about this gap here. This gap here, it was not supposed to be there, right? It's not supposed to be there. So don't worry. Let it not confuse you. All right. So after you have your interval, so in this case they've already given us the interval. You can see on the left side there. The first class we have a lower limit of 0 to 9. The second class from 10 to 19. So obviously, this is the classes that the person used, right? And now he grouped the people based on the class or the mark that they got. So if they got a mark of 50, he had to come under 52, 59. That's where the person will this is unit 2, right? Just go on unit 2. I may not be particular on the page, but this is unit 2, where we are talking about data presentation. So it's under a unit called data presentation, right? That's where you get this information that we are talking about here. All right, so now when you group, right, the people based on the specific range of marks that they fall into, then you need to create what is called a cumulative frequency. So basically, there are 2 ways. I want you undivided attention on this one, right? I want to show you how to calculate this cumulative frequency. So cumulative frequency, there are 2 ways, right, of doing it. So the first one and the most easiest one is when you are calculating the cumulative frequency of a class, you add all the frequencies of the class before this class, right? Like in this case, the first class is a frequency of 1, and there is no previous class before it, right? So obviously there's a frequency of 0 because there is no previous class on it. So you say 0, which means no previous class, plus the frequency of the current class, which is 1, it gives you the cumulative frequency of 1. Then when you come to the second class, you see that it has a frequency of 2. Then there's 1 class before it, and it has a frequency of 1. So you say 1 plus 2, then you get your 3, right? Then when you come to the third class, you know that the frequency of the class is 5, and then you add all the frequencies of the class above it. So you say 1 plus 2 plus 5, then you get your 8, right? When you come to the fourth class, you say 1 plus 2 plus 5 plus 6, get your 14. When you get to the fifth class, you add all the classes before it, including the class, and then you get your number up until you get to the last class, right? So like example, the last one, you add all these numbers plus 1, and then you get your 100. So that is the easiest way of doing it. Then, okay, someone saying, please repeat. All right. So what I'm saying is, so this is the first way. I'm going to say another one. So you choose the one that will suit you better, right? So what I'm saying here is cumulative. It means you are just adding, right? That's what cumulative means, the word cumulative, right? So here when we say cumulative frequency, you are just adding the frequencies, right, together. Basically, that's what we are doing, right? So the first method, what you are doing is you will add the frequency of the class with all the frequencies of the class before it. So on the first class, we have a frequency of 1, but we don't have a class before it, so we put 0, right? And then we say 0 frequency of the previous classes plus 1, it gives us 1. Then we have a cumulative frequency of 1. Then when we get to the second class, right? The second class, we have a frequency of 2. Then let's check what are the frequencies of the class before it. We only have 1, right, of the previous class. So we then add the frequency of the current class plus all the frequencies of the class before it. So it will be 1 plus 2 to get this 3 here. Then when we get to the third class, we then say 5 of the current class plus all the frequencies of the class before it. So it will be 1 plus 2 plus 5, because we have got 2 classes before this class here. So we add all the frequencies, 1, 2, 3, and then when you add 1, 2, and 5, you get your 8. Then when you get to the fourth class,
Kuda,
yes.
I just wanted to ask is, wouldn't it be much easier if you add the frequency to the total of the cumulative frequency that you got? The previous
Yes, that is, sorry, that is I think I muted you by mistake there. Sorry. I think that is the second method. So you are actually correct on that one. So you can see that one of you guys has actually figured out that there might be another easier way rather than adding everything at once, right? She then tells us of the second method that I'm going to tell you about, where you are going to add the cumulative frequency of the, okay, I'll get there. I'll explain to you what she's talking about. So I don't want to confuse you, but you are correct. You are correct on what you are saying there. You are very, 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 very correct. That is the second method that I wanted to talk about there. So just finishing up on that first method. So you see that what you are just doing, basically, you are coming to the class that that you want to calculate the cumulative frequency of. Then you add all the cumulative frequencies of the classes before that class, right? Including the frequency of that class. So like in this case, the last class has got a frequency of 1. Then we add all the frequencies of these classes before it, including this 1, and then we get 100. Then coming to the method now that has been that one of your colleagues was talking about. This one, I think this is much easier than the one that I was presenting. So what you do is you say the frequency. So you just know that the frequency of the cumulative frequency of the first class should be equal to its frequency. So in this case, the cumulative frequency of the first class should be equal to this frequency. That is this 1 here. So once you have this 1, to get this 3, you then say the cumulative frequency of the previous class, because we want to find the cumulative frequency of this class, right? So you come in to say the cumulative frequency of the previous class plus the frequency of the current class. So you say 1 plus 2, then you get your 3 here. Then when you come to 5, we want to find the cumulative frequency of 5 here, right? Then you say the cumulative frequency of the previous class. So the previous class to 5 is this class, right? So this is the cumulative frequency of the previous class. Then you say 3 plus 5, and then you get your 8. Then you come again to the next class. This is the class that you want to find the cumulative frequency of. Then you say the cumulative frequency of the previous class, which is 8, plus 6, then you get your 12 there. So, okay, someone is saying the second method is zigzag. Okay, so that's why I'm giving you the two options, right? Because at the end of the day, the first method and the second method, they will give you the same answers. So if you see that the second method is a little bit difficult for you, stick to the first method. If you think that the first method is difficult for you and the second method is easier for you, then choose the one that suits you better. All right. Someone saying we like the zigzag one. Okay, that's fine. So obviously when we come to this next class here, right? So you say this is the class that we want to find the cumulative frequency for, right? But then you say, what is the cumulative frequency of the previous class? You see that it is 14, and then you add it with the frequency of the current class, 14 plus 29, and then you get your 43. So that's the same up until you get to the last one, where you say 99 plus 1, and then you get your 100. All right, so you still get the same answers, right? So when we get to this part here, right, you just have to choose the one that suits you better, right? So when we start the calculation, remember this is an overview of the theory, right? When we start in the next lecture, when we start with the calculations, I'm going to show you on Excel. In this module, Excel is going to be our best friend, because I don't want you guys to do, the longer way, right? Because your examination, it is multiple choice. So you don't show workings, right? So obviously, instead of you, writing your formulas down and everything, I'll show you in Excel, because Excel is a calculator on its own. So I will show you ways of implementing Excel in this module so that it will make life easier for you. So if we are using Excel, I know right now it looks like it's a zigzag, but when we use Excel, we will now be using a formula. So in just Excel, you will just drag down and everything will be filled on its own using Excel, right? So don't worry, I'm going to show you again using Excel, this method, how you can create cumulative frequency in a much faster way, right?
Buddha?
Okay, yes.
Just for the intervals, because
Mhm.
now it's like 0, 9, and 10 to 19. Would we then be able to say maybe 0 to 10, 11 to 20? What would determine what is your lower limit and your upper limit? If it's not
Okay.
given to you like in the left-hand side there.
Okay, so in this case, what? All right. So in this case, what determines whether why we used 0 to 9 and not 0 to 10 is because this person had told us that they used an interval size of 10. So if you start to count 0 on your first finger, you will see that the 9th position will fall on your 10th finger, right? If you start counting, if you say your first finger is 0, right? When you count and you get to the 9th position, you will see that it will fall on your 10th finger, right? So the interval size is, in this case, it is 10. So 10 now, if you say 0 to 10, here, right? If you count on your fingers, this will not be 10, but this will be 11. Remember, I don't know if you were present last week. Last week, I told you that if you want to calculate what is called the class width, you don't say the upper limit minus the lower limit. That would be wrong. What you do is you say it's either you choose lower limit boundaries or upper limits boundaries. So if we choose lower limit, we'll say the lower limit of the second class minus the lower limit of the first class. So if you say 10 minus 0, you will get 10, which is this 10 here, right? If you choose upper limits, you will say 19 minus 9, which will still give you 10. So what allowed us to say 0 to 9 is this number here, 10, because when we count starting from 0, our 10th right number falls on the ninth number there. All right. Yes, Salome, you may You may
Good
unmute
evening.
yourself.
I just take a
That I
quick one.
answered you before. Sorry?
I thought you were still speaking to the previous candidate.
Oh, yes. Oh, okay. So before you ask your question, I'm hoping that I answered you correctly. If not, please just iterate where maybe you want me to clarify, or you are okay now.
I'm okay, thanks. I'll go through
All right.
last week's class as well, just to check.
Okay, no, that's fine. Okay, so Salome may go
Okay,
ahead.
still on the interval. Yeah, still on the interval. Say for an example, we were given okay, the case of 100 and the lowest mark is 0 and interval starts with of 5, not 10. 5.
Yeah.
So was my triple gonna be like 0, 4, then 5, then 4, 5, 9, and then I was zigzag as we're zigzagging.
Okay, so if I'm getting you correct, you are saying maybe let's say that your class width is 5. So your first class interval will be 0 to, let's say,
4.
because you
Yes,
start
and then
to
5 there,
0, then 5 here, and then we say 9.
and then 9.
Yeah. Let's see
It was gonna
5,
be like that.
6, 7, 8, 9. Yeah, that's correct. Yes, it will be correct. That will be
Wow.
the thing. Because at the end of the day, if it is 5, you should be able to say 5 minus 0, it should give you 5. If you say 9 minus 4, it should give you 5.
Oh, okay.
Yes. So the trick that determines the one that will be here, right, or here, is what is called the class width. So if you are given
Okay.
the first value here, your class width is the one that will determine the limit here and the limit there, and also the
Okay.
limit here. Yes. So were you here last week? You were
No,
not here, ne?
I was not. Yes.
Yes. So I explained this in much deeper detail in the previous video.
Okay. Okay.
Yes. So we are going also so today I was just explaining about data presentation, but I'm going to explain this in detail next week when we start to do what is called the measure of central tendencies. So I'm going to show you now how now this class width is used to determine, these limits.
Yeah.
Given the first value here.
Okay.
But just to have an idea, I explained it in detail last week. So just get the video from James. I think it will give you an idea before we get into the next lecture next week.
Okay, but just a quick one. So does
Yes.
that mean if I was given width of 10, width of 5,
Yeah.
then on my lower limit, was I going to have like 5, 10, 15, 20, 25, 30, 35? Because here
If
you were
you're
given
given
10, it went like 10,
for
20,
class
30,
width,
40, 50.
for class width, I think you said 2 figures. Which one are you talking about, 10 or 5? Because you can't
Now
be given
I'm
both.
still on my example of 5.
Or
With your
5,
example
okay.
of width of 10 is 10, 20, 30, 40, 50 on the lower limit of the interval. So if I was given 5, was it going to be 5, 10, 15, 20, 25, and so on?
It can't be 5, 10. Because
Okay.
remember, it can't be 5, 10. It will be 5, 9. All right, let's do this, Salome. Can you just go and see?
No,
Sorry,
I
Kuda.
think Kuda, you are confusing
Kuda.
here. You are confusing. You are
Yes.
confusing
Yeah,
here. You're talking about
I think
the
what she,
lower limit. The
I
lower
think what
limit
she,
aside.
oh, sorry.
Sorry,
Okay. There are two people that are talking. Sorry, guys. Yes. There was one who was okay. Who wants to go first? I think there were two of you that were speaking at once.
Okay, sorry about that, guys.
No, that's fine.
Okay, so the lady is talking about if you look at the lower limit, right? On the
Yes.
interval, the lower limit that you currently have now under the cumulative frequency table, it says 0, 10, 20, 30, 40, 50, up until 90. So on the example that she was doing there, the one that says 0 to 4, right? And then 5
Yes,
to 9.
yeah.
So
5 to
from
9,
9,
yes.
Yes, going down
get
on
to
the
10.
lower on the lower limit, it's going to be 5, 10, 15 going down, which is she's correct.
Yes.
Yes.
Oh, that's
she's
what I was
correct
asking.
saying.
Oh, thank you. You understood me. Thank you so much.
Yes.
Okay.
Okay,
Right.
no
I
Yes.
understand that. Thank you
Okay.
so
If
much.
that was the question, yeah, then
That was
yeah,
the
you were
question.
correct.
That was the
Okay.
question.
All
Okay.
right. So you were correct. So it will be 0, 5, 10, 15. Then here it will be 4, 9, 14, 19, going like that. So what you just need to know is when you subtract these two, you must have these 5 coming out. If you subtract these 2 neighboring, you still have to find 5. Because that's the
Yes,
class.
that I understand. That I understand clearly. Thank you so much.
All right. No, that's fine. Then there was a lady who was also asking something. I think asking or maybe saying something in the background.
No, I just wanted to clarify that misunderstanding.
Oh, okay. So you are okay.
Yes, you can carry on.
Oh, all right. No, that's fine. Okay. So guys, I'm supposed to be having a lecture now at 8. So what we are going to do, let's end here. Next week, because I'm only left with let me see. So the slides that we were supposed to cover, the theory today. So I was only left with, we were supposed to talk about these ones. And then we were supposed to start this, the calculations here. All right. So because of our time, let's end here. Then next week, let's pick it up on presenting data using graphs and charts, right? Then when we finish this, we get into our calculations. Then we get into the calculations. Then from there, we'll be continuing with the units of the study guide. So before we close, are there any other questions?
Yeah, sorry, I had my hand up.
Oh, okay. Sorry, sir. I didn't see that.
All right, no problem. Sorry, I joined late because somehow I didn't receive an invite and Tumi had to send me the invite.
Okay.
Just with regards to the frequency. Okay.
Yes.
You're collecting the frequency from the raw data chart, hey?
Yes, yeah, from this previous table.
Right. Okay. So that's where I got a bit confused. Okay. All right. I got it. Thank you.
But so you're okay now?
I'm okay. Thank you.
All right. No, that's fine, sir. Okay. So thank you so much, guys. So for those that want to join the lecture, just talk to James. I think the issues of time, the money, I think we discussed last time. If you are not around, just get a hold of James. He will tell you everything. For those that are going to join us, let's meet same time next week. For those that are coming for information management, we'll meet tomorrow, same time. Have
All
a
right.
lovely
Please
evening.
ask James to send us a message again.
Oh, okay.
All right. Thanks.
All right, that's fine. I'll tell you.
Okay, thanks. Bye.
All right. All right, bye, guys.
Thank you, Kuda.
Bye.
Bye.
Thanks.
Night, everyone.
Night.